Risc Os is a computer operating system originally designed by Acorn Computers Ltd in Cambridge, England. First released in 1987, it was specifically designed to run on the ARM chipset, which Acorn had designed concurrently for use in its new line of Archimedes personal computers. Risc Os takes its name from the Risc architecture supported. Between 1987 and 1998, Risc Os was bundled with every ARM-based Acorn computer model. These included the Acorn Archimedes range, Acorn's a line of computers, RiscPC, A7000 and also prototype models such as the Acorn NewsPad and Phoebe computer. A version of the OS was also used in Oracle's network computer and compatible systems. After the breakup of Acorn in 1998, development of the OS was forked and separately continued by several companies, including Risc Os Ltd, Pace Microtechnology and Castle Technology. Since then, it has been bundled with a number of ARM-based desktop computers such as the iUnix and A9 Home. As of 2012, the OS remains forked and is independently developed by Risc Os Ltd and the Risc Os Open community. Most recent stable versions run on the ARMv3/ARMv4 RiscPC, the ARMv5 iUnix, ARMv7 Cortex-A8 processors and Cortex-A9 processors. There is a development version for the Raspberry Pi. SD card images have been made available free of charge to Raspberry Pi users with a full graphical user interface version and a command line interface-only version. History. Risc Os was originally released in 1987 as Arthur 1.20. The next version, Arthur 2, became Risc Os 2 and was made available in April 1989. Risc Os 3.00 was released with the A5000 in 1991 and contained a series of new features. By 1996 Risc Os had been shipped on over 500,000 systems. Acorn officially halted work on the OS in January 1999, renaming themselves Element 14. In March 1999 a new company called Risc Os Ltd licensed the rights to develop a desktop version of Risc Os from Element 14, and continued the development of Risc Os 3.8, releasing it as Risc Os 4 in July 1999. Meanwhile, Element 14 had also kept a copy of Risc Os 3.8 in-house, which they developed into NCOS for use in set-top boxes. In 2000, Element 14 sold Risc Os to a company called Pace Microtechnology, who later sold it to Castle Technology Ltd. In May 2001 Risc Os Ltd launched Risc Os Select, a subscription scheme allowing users access to the latest Risc Os 4 updates. These upgrades are released as soft-loadable ROM images, separate to the ROM where the boot OS is stored, and are loaded at boot time. Select 1 was shipped in May 2002, with Select 2 following in November 2002 and the final release of Select 3 in June 2004. In the same month, Risc Os 4.39, dubbed Risc Os Adjust, was released. Risc Os Adjust was a culmination of all the Select scheme updates to date, released as a physical set of replaceable ROMs for the RiscPC and A7000 series of machines. Meanwhile, in October 2002, Castle Technology released the Acorn clone iUnix PC. This ran a 32-bit variant of Risc Os, known as Risc Os 5. Risc Os 5 is a separate evolution of Risc Os based upon the NCOS work done by Pace. The following year, Castle Technology bought Risc Os from Pace for an undisclosed sum. In October 2006, Castle announced a source-sharing license plan for elements of Risc Os 5. This shared source initiative is managed by Risc Os Open Ltd. Supported hardware, versions of Risc Os run or have run on the following hardware. Note that Risc Os Open Ltd adopted the even numbers as stable version numbering scheme post version 5.14, hence some table entries above include 2 latest releases the last stable one and the more recent development one. Risc Os has also been used by both Acorn and Pace Microtechnology in various TV-connected set-top boxes, sometimes referred to instead as NCOS. Risc Os can also run on a range of computer system emulators that emulate the earlier Acorn machines listed above. Features. OS core equals, the OS is single-user and employs cooperative multitasking. While most current desktop OSes use preemptive multitasking and multi-threading, Risc OS remains with a CMT system. By 2003, many users had called for the OS to migrate to PMT. The OS memory protection is not comprehensive. The core of the OS is stored in ROM, giving a fast boot-up time and safety from operating system corruption. Risc OS 4 and 5 are stored in 4 MB of flash memory, allowing the operating system to be updated without having to replace the ROM chip. The OS is made up of a number of modules. These can be added to and replaced, including soft loading of the modules not present in ROM at runtime and on-the-fly replacement. This design has led to OS developers releasing rolling updates to their versions of the OS, while third parties are able to write OS replacement modules to add new features. OS modules are accessed via software interrupts, similar to system calls in other operating systems. Most of the OS has defined APIs to handle filters and vectors. The OS provides many ways in which the programmer can intercept and modify its operation. This simplifies the task of modifying its behavior either in the GUI or deeper. As a result, there is a number of third-party programs which allow the OS look and feel to be customized. File system equals, the file system is volume-oriented, the top level of the file hierarchy is a volume prefixed by the file system type. To determine file type, the OS uses metadata instead of file extensions. Colons are used to separate the file system from the rest of the path. The root is represented by a $sign and directories are separated by a full stop. Extensions from foreign file systems are shown using a slash. For example, ADFS hard disk 4. $is the root of the disk named hard disk 4 using the ADFS file system. Risc OS file types can be preserved on other systems by appending the hexadecimal type as XXX to file names. When using cross-platform software, file types can be invoked on other systems by naming appending / extension to the file name under Risc Os. A file system can present a file of a particular type as a volume in its own right, similar to a loop device. The OS refers to this functionality as an image filing system. This allows transparent handling of archives and similar files, which appear as directories with some special properties. Files inside the image file appear in the hierarchy underneath the parent archive. It is not necessary for the archive to contain the data it refers to. Some symbolic link and network share file systems put a reference inside the image file and go elsewhere for the data. The File System Abstraction Layer API uses 32-bit file offsets, making the largest single file 4 GB long. However, prior to Risc OS 5.20, the File System Abstraction Layer and many Risc OS native file systems limited support to 31 bits to avoid dealing with apparently negative file extents when expressed in 2's complement notation. File formats . The OS uses metadata to distinguish file formats. Some common file formats from other systems are mapped to file types by the MIME map module. Kernel . The Risc OS kernel is single-tasking and controls handling of interrupts, DMA services, memory allocation and the video display. Desktop . The WIMP interface is based around a stacking window manager and incorporates 3 mouse buttons, context-sensitive menus, window order control and dynamic window focus. The icon bar holds icons which represent mounted disk drives, RAM disks, running applications, system utilities and OCT files, directories or inactive applications. These icons have context-sensitive menus and support drag-and-drop behavior. They represent the running application as a whole, irrespective of whether it has open windows. The GUI is centered around the concept of files. The filer, a spatial file manager, displays the contents of a disk. Applications are run from the filer view and files can be dragged to the filer view from applications to perform saves. Application directories are used to store applications. The OS differentiates them from normal directories through the use of a pling prefix. Double-clicking on such a directory launches the application rather than opening the directory. The application's executable files and resources are contained within the directory, but normally they remain hidden from the user. Because applications are self-contained, this allows drag-and-drop installation and removal. The Risc OS style guide encourages a consistent look and feel across applications. This was introduced in Risc OS 3 and specifies application appearance and behavior. Acorn's own main bundled applications were not updated to comply with the guide until Risc OS Limited Select release in 2001. Font Manager The Outline Font Manager provides spatial anti-aliasing of fonts, the OS being the first operating system to include such a feature, having included it since before January 1989. Since 1994, in Risc OS 3.5, it has been possible to use an outline anti-aliased font in the window manager for UI elements, rather than the bitmap system font from previous versions. Risc OS 4 does not support Unicode, but Risc OS 5 provides a Unicode font manager which is able to display Unicode characters and accept text in UTF-8, UTF-16 and UTF-32. Other parts of the Risc OS kernel and core modules support text described in UTF-8. Bundled applications Risc OS is delivered with a number of desktop applications in the form of pre-installed software. Backward compatibility, limited software portability exists with subsequent versions of the OS and hardware. Single-tasking BBC Basic applications often require only trivial changes, if any. Successive OS upgrades have raised more serious issues of backward compatibility for desktop applications and games. Applications still being maintained by their author, or others have sometimes historically been amended to provide compatibility. The introduction of the RiscPC in 1994 and its later strong ARM upgrade raised issues of incompatible code sequences and proprietary squeezing. Patching of applications for the strong ARM was facilitated and Acorn's unsqueeze AIF software unsqueezed images according to their AIF header. The incompatibilities prompted release by the ARM Club of its Game On and StrongGuard software. They allowed some previously incompatible software to be run on new and upgraded systems. The version of the OS for the A9 Home prevented the running of software without an AIF header to stop trashing the desktop. The Unix PC and A9 Home saw further software incompatibility because of the deprecated 26-bit addressing modes. Most applications under active development have since been rewritten. Static code analysis to detect 26-bit only sequences can be undertaken using Armalizer. Its output can be helpful in making 32-bit versions of older applications for which the source code is unavailable. Some older 26-bit software can be run without modification using the emulator. Additional incompatibilities were introduced with newer ARM cores, such as ARM-v7 in the Beagle board and ARM-v6 in the Raspberry Pi. See also, Acorn C++, Drobe, Riscos.info, ROX Desktop, a graphical desktop environment for the X Window system, inspired by the user interface of Risc Os. References. External links. What is Risc Os? The Risc OS Products Directory. November 2, 2006. Archived from the original on February 19, 2007. Retrieved August 26, 2014. Gilbert, Michael. Archaeology, Relics from Acorn's Past louisgilbert.co.uk. Retrieved August 26, 2014. Watson, Jamie. A Raspberry Pi, Hands-on with Risc Os. ZDNET. CBS Interactive. Retrieved August 26, 2014. Watts, Robin. Documentation on Acorn Computers. Warm Silent Software. Pink Noise Productions. Retrieved August 26, 2014.